OK, now it's time to get specific. We've talked about the architecture of SAS apps in general. We talked about model view controller. And now it's time to start a tour of the actual Rails framework so that we can start tying some of these concepts concretely to what Rails does for each of these things. So if you create a new Rails app, or if you use the Rotten Potatoes app that we've created for the course, and you take a look at what's in the directory, the sort of root directory of the app, here's a bunch of stuff that you'll see. We're not going to look at everything that's in the main directory, but you'll find a gem file, you'll find a rake file, and now you're going to start seeing directories that correspond almost exactly with the concepts we've been talking about. So in terms of our little architectural diagram, which I have cleverly reproduced in miniature, there's a directory called app, which has subdirectories, models, views, and controllers. You could probably figure out what's in those directories based on our walkthrough of the app so far. So we know that the app is organized around MVC, and we know the roles that each one of those things plays. So for example, given that we said each type of thing, for example, a movie, has its own model, its own set of views, and its own controllers, you can imagine what you might find in these directories. What else, if we continue our tour? We talked about using style sheets as a way to style the presentation to the user. There's a directory called assets in which you'll find style sheets. You'll find a place you can put JavaScript, which we're going to learn about later, and other interesting stuff. We talked about the idea that Rails has a separate routing subsystem so that you don't have to sort of mix in hardwired URIs into your code. Instead, you specify what actions you want to support on what resources, and Rails provides machinery for generating those URIs for you. In the config directory, you'll find a file called routes.rb, which is how you specify what actions you want to do. And as your app starts up, the information in that file is used to automatically build those mappings at runtime. There's also a directory called DB for database. As we know, the database is where the model's data actually lives. And one thing we're going to see very shortly when we talk about how Rails deals with databases is that you can have more than one. In particular, there's one that you use for real in production, there's one that you do your development on, and there's another one that's just for running your tests. You'll find all of those, or at least the information about how to get at them, in the DB subdirectory. So what about, how does Rails sort of act as an MVC framework? Here's a picture that we used from a long time ago showing that your web browser goes in through the presentation tier. That's where the web server lives. It hits your Rails app, and at some point it'll probably get data from the database. So specifically, what's inside your app? Well, in the Rails world, the first thing that happens is your incoming request from the browser is going to hit one of the controllers. And where is the controller code? It's in the controllers directory, just where you would expect to find it. This is a theme that we're going to keep coming back to. If you do things the way that a reasonable person would expect, there's a lot of work that you don't have to do. The Rails routing subsystem is responsible for mapping the incoming URL to the right controller and the right action, or for signaling an error if there is no match. The controller will probably ask the model to do some work for it. And what is a model? It's a bunch of code somewhere in the model subdirectory, appropriately enough. We know that because Rails is using active record, that means that there's a relational database, and each model has a table in that database where instances of that model are stored. Once the model has returned some data back to the controller can hand that off to a templating system like Haml. The views will get rendered by interpolating the data that came via the controller. That gets returned back to your browser. So what are the models? As we're going to see, they're subclasses of active record base. The views are subclasses of action view, and the controllers are subclasses of application controller. So this is an example of how you use the features of a language that has class hierarchy and inheritance to support a framework, right? If we're saying that active record has common machinery that all models can use, and then there's specific machinery associated with your particular type of model, that's exactly a case for using inheritance, because we want to reuse implementation, right? The implementation of the common functionality of active record should be shared by all models. So it makes sense to make models a subclass of some base model that has the functionality that's common to all of them. And you can make a similar argument for views and controllers. So this is sort of a good use of inheritance, right? We have commonality across different kinds of things. There's a certain amount of that commonality that we want to capture a common implementation that they all can reuse. Inheritance is a way of reusing the implementation. So let's take a trip through a Rails application, a very quick one. What happens, I'm just putting some detail and text behind that diagram. We have routes that we define for our own application in routes.rb. They map the incoming request URIs to controller actions. As we saw, those controller action routes can include optional arguments, like an argument that identifies, or a parameter that identifies a particular resource. Those get extracted for you. And here's an example where we're visiting an app running on our local machine, and we're going to do get/movie/3, continuing the example from the previous segment. So in this case, routes.rb is going to be consulted, and there will be a mapping, because this is one of the default routes that Rails provides for us, saying you should be looking at the movies controller and call the show action within that controller. Now, where are these things going to be located? Well, we'll show in a moment that convention over configuration means that if we choose to follow some default rules about how things are named and where they're located, we don't actually have to explicitly tell Rails where to look. It will basically figure it out. The controller actions can do pretty much whatever they want to get at the data. And once they're done, they can set up instance variables that will be visible to the views. So this is how information is actually communicated from the controller subsystem to the view subsystem. Any controller instance variables that are set up in the controller action automatically become visible to the view. Now, you might say, and I hope you would say because you've been listening so closely, wait a minute, Armando, you just said that the views are subclasses of one thing, action view, but controllers are subclasses of this other thing, action controller. So how is it that setting instance variables in something that is a controller could result in those instance variables becoming accessible to something in a totally different class? That makes no sense at all. And you'd be right. So what Rails actually does, remember we talked about metaprogramming? Ruby allows you to write code at runtime, modify classes at runtime. What basically happens is that an action view instance is created, and new instance variable attributes are injected into it using metaprogramming so that its instance variables will match the ones that you set up in your controller method. So, and it doesn't matter what they are, right? Remember that in Ruby we can ask any object about itself. So the controller method can ask about itself, what new instance variables did the programmer create and use in the controller method that were not already instance variables of the controller itself? And for every one of those, I'm going to create a version of that variable with the same name in this other object of another class called ActionView. Why would you do this? Because it's easy for programmers. You set up the instance variables, and then you can just use them. That's the reason to do it. It makes life simpler for the programmer, right? And Rails and Ruby are all about simplifying your programming. So the controller can set an instance variables that become visible to the views. And where does it find the views? Well, as we'll see, if you have a controller action called, for example, show, which shows a movie, well, it'll just look in the views subdirectory for movies and look for show.html.haml, because that's reasonable, right? We're going to talk a lot more about convention over configuration. So here's an example of what our controller action might look like. We get the ID of the movie that we wanted to look up. This comes from the URI. The route subsystem pulls that out for us. As we'll see, this is one of the ways that we can tell the movie model to do the R in CRUD, find the database record whose ID is this, assign it to this instance variable mv, and magically that instance variable will become available to us in the view. The view might have a little piece of stuff in it that looks like this in Haml, a list item saying the rating of this movie is, and an interpolation saying mv.rating. Why does this work? Because mv is just a movie variable. Movie has an attribute called rating, and we can dereference it. So the goal is to make the code look like the way that you should expect it to work. It's really to minimize the number of surprises when you're looking at the code. The Rails philosophy that underlies a lot of this, and we're going to see many examples of, a couple of philosophies. One of them is convention over configuration. And basically this says you follow certain rules, and in exchange, there's a lot of things that you won't have to worry about in how to find stuff or where stuff is named. An example would be that if the movie's controller, it's a controller we define, so it's a subclass of action controller, and we want to define an action or a method in that controller called show, well, Rails will expect that the controller's subdirectory includes movies_controller.rb. So basically the rule is you take the name of the thing, you pluralize it, and you add _controller. It will expect that at the end of the show action, because it's going to want to render a view, that unless you say otherwise, it should look for the movie subdirectory in views and show.html.haml in that subdirectory. Now again, you can override all this whenever you want, but if you override it, you end up doing more work, because now you have to tell it where to actually look for these things. And as you might guess, the ability to introspect on Ruby objects and ask questions about themselves, like what is my name, right? What is the name of this variable? What is the name of me? Is how Rails is able to then look up things with the corresponding name and find them in certain directories. Part of this is the don't repeat yourself philosophy, or DRY. If you can figure out the names of things like files and actions and templates just by applying some simple rules to the names, then there should be no need for you to have to explicitly repeat that information somewhere else. That's just one more place you have to update whenever your app changes. So we'll see many mechanisms not only using convention over configuration to be dry, but also to extract common functionality so that you can reuse it from many places. And both of the mechanisms, the examples that we'll see, rely very heavily on Ruby language features. So this is why people will often say, well, Rails is just a framework. You could do a framework just like Rails, but it would be in Java instead of Ruby. It's actually not that simple, because a lot of the things that make Rails apps as concise as they are is the fact that you can get away with a lot of, essentially not explicitly putting in a lot of information, because you can use introspection to infer the information, and you can use metaprogramming to create new objects at runtime that look the way the programmer expects. If the language doesn't support that, you might think you have something like Rails, but the parts of Rails that really buy you simplicity and compactness will be largely absent from it.